JSON. We hear about it all the time. In fact, most of us have worked with JSON in some form or another. JSON stands for JavaScript Object Notation, and it is the most common data interchange format. It is used for describing and exchanging text-based data. If we're dealing with web-based applications for accessing data services, or using APIs to access data services, most likely we are receiving or sending data via JSON format under the cover. Now, JSON is great for a number of reasons. Number one, it is human readable. It certainly is more readable than XML format, and it is categorized as semi-structured data, which means that it does not have to conform or adhere to tabular structures, such as fixed schemas or tables or data types of data models that we usually see associated with relational databases. Now, with Snowflake, when working with JSON data, it is extremely easy. Right? Snowflake has native support for semi-structured data. It makes it very, very easy to work with JSON data using SQL. We can use SQL to load, unnest, query, and join JSON data with other tables or data. And semi-structured data can be highly nested. It can contain n-level of hierarchies of nested information. Semi-structured data can be loaded into Snowflake in the form of relational tables without requiring a schema to be defined in advance. You don't have to pre-create a schema or a table that matches a schema before you can load it. And the variant data type, in fact, is very core to working with semi-structured data. The variant data type itself can store a value of any other type, including object and array, and it allows semi-structured data to be loaded into a column. And once loaded, Snowflake automatically understands the structure, the attributes, and the keys that come with the actual JSON document. So here we have just a quick example of how you can deal with JSON data, how you can actually nest and parse and query JSON data. I'm using a worksheet here in Snowflake in Snowsite. The first thing I did was I created a file format which defines it to be of a type JSON with these different attributes here. And second, I created a table that is called nested ingest JSON with a column of the variant data type. And after that, I actually use the classic console UI to load the data into this table here. The file itself comes from my desktop. Now, at the time of recording this, the actual classic console itself has been decommissioned. So now when we log into the Snowflake web user interface, it takes us straight into the new Snowsite UI, which no longer has access to the classic console. Within the new user interface, you don't have a UI function to be able to load data. So what you could do is you can actually use NoSQL client and run a put and a copy command to actually load JSON data into your table. So now that we've loaded the data, let's do a quick run and see what we get here. You can see that we've got 5 rows here. First row itself has a nested structure. Authors, we happen to have 2 authors working on the same book for this particular title. This title was related to food and it was published in the year of 2001. Now, if we want to just query on authors only, we can actually do that by running this command. By the way, we've referenced the attribute name authors is through this format here. We run this, you see that it comes back with 5 rows. First row has actually 2 authors. Now if we want to look at just the first author in every single row, we can reference it by using an array indexed. Here we're returning the first name, the first author in every single book that we have. Now if we actually want to unnest all the authors for all the records, we can actually use what we call a flatten function. Now, the flatten function itself can be used to convert semi-structured data to a column format or relational representation. And the flatten function can take either a variant, an object, or an array column and produces an inline view. So here we've got a SQL that's going to pull the first and last name of each author, along with that the associated book and the year that the book was published. And we're calling the flatten function against the column or the attribute called authors. So we just run this, and what we get is this. Right now we've got 6 records instead of 5 because we've unnested the first row to become 2 rows because we had 2 authors associated with this particular book here. Right. Another way of using flatten is instead of calling the lateral flatten, you just call table and nest it with the flatten function. It basically does the same thing. Okay. Similarly, moving on to a more complex JSON example. Here we've got tweets that are related to nutrition. You can see that it has a lot more attributes, and it certainly is highly nested. Right, so coming back to our worksheet, we're just going to do a quick select on this tweet. You can see that each row contains a lot of information. We've got nested information under the entities, which includes hashtags as well as text and URLs, etc. To unnest that, we simply construct the SQL here, again using the flatten function itself, and we're calling the flatten function against two attributes which are of the list nature. So entities hashtags has multiple records. We want to unnest this. So also want to unnest the multiple URLs that are related to the entities. So here we'll click run, and what we get is this is the result of it. Text, just the name, the topic related to the tweet, as well as the URLs that are associated with those tweets, and here we've got a date timestamp for that particular tweet. Similarly, we can apply recursive nesting by specifying the recursive property in the SQL itself. So taking the same SQL, simply just adding recursive to it, now it's going to unnest every single level that we see in our JSON data structure. We had about 9 rows before, now we end up with 315. So you can see that how quickly you could deal with semi-structured JSON data in Snowflake, especially for those that are SQL coders, or those that love to write SQL to wrangle the data. This is a great and easy way of dealing with semi-structured data. So the question is, what if you're a non-technical user, or writing SQL is not your thing, or you simply wish to have a more visual way of inspecting your JSON data while working with it? And this is where Alteryx Designer Cloud comes in. Alteryx Designer Cloud could be a great solution for you. By the way, Alteryx Designer Cloud has a great integration with Snowflake. In fact, Snowflake is one of the top cloud data warehouse platforms which our customers use with Alteryx Designer Cloud in their environments. And Alteryx Designer Cloud is highly optimized for Snowflake processing with full pushdown capability as well as secure authentication using OAuth. Users can easily access data in Snowflake using Alteryx Designer Cloud through a self-service fashion to prepare, to cleanse, and to transform the data with a very intuitive and interactive user interface. So here I am, I've got a flow. I'm going to add the same data set that we're using in Snowflake. I click on add. I want to do an import, go into public, and what we're looking at was a nested ingest JSON table schema, which is in public. Now I can quickly preview the data. I can add that to my flow. Now once I've added to my flow, I can actually preview the data, and you can see that it has 5 rows. Each row has nested information. By the way, at this point, Alteryx Designer Cloud has already detected the proper format, which is JSON, and it's displaying it with the different attributes for us. Now we can open up this data set and begin to work with it. And one of the most impressive things about Alteryx Designer Cloud is that its interface is extremely easy to use, highly intuitive, and its guide is driven by the user's intent, meaning that as you interact with the data, it will suggest the type of transformation to you, and it will show you what that transformation looks like before and after. So here we can see that it's already detected the JSON data type, and it's telling me that I've got 3 key attributes: authors, book title, and year published. And for each record, I can actually see the values associated with the attributes. Now, before we unnest this, what we want to do, certainly we can see that there are new line characters which we don't want in our data. Now, to remove this, I just simply brush over. Alteryx Designer Cloud then gives me the option to deal with this. Now, what we're looking for is the ability to replace these. So I can come down here to the replace option, and I can say I want to replace this new line character with nothing, meaning I want to remove it. And as I clicked on that, Alteryx Designer Cloud displays to me the actual outcome before I commit to it. You can see that here we've got new line characters. This is the after picture of it, where new line characters have been removed. So I select that, I'll add that to my recipe. Now I can begin to unnest my data. To unnest data, I simply just click on the column. By clicking on the column, I get an option to unnest values. I can do this. You can see that as I mouse over, it's showing me the actual outcome of what that looks like. Now, if I don't wish to unnest everything, I just want to unnest certain attributes, I could simply select or click on these attributes. For the purpose of this demo, click on unnest, select this option, check the outcome, and you can see that here we've got 5 rows, but there are 6 unique items, so we end up with 6 rows just because our first row contains 2 authors. So it is unnesting the sub entries for us automatically, and I clicked add, right? So now I end up with these 6 unique items. Now within each item, I can further unnest the attributes that I prefer or that I wish to do. In this case, I would just go ahead and convert everything into rows. Now I end up with 6 rows with 6 different authors and their associated books. This is how quickly and easily non-technical users can work with JSON data. By simply clicking on the histogram bars that represent the different attributes, users can unnest the data immediately and have the visual view of the outcome. Now let's take a look at a more complex data set. You can see that with tweets, this one here certainly has much more information. It's much more nested. Same thing. I'll first remove the new line character. And now we can begin to unnest certain attributes. What I'm interested in is the entity. Highlight on that. Check the outcome. Add. Now with my new entities column, I can further isolate or expand on my information, or nest my information. Maybe I'm interested in both hashtags and URLs attributes. I clicked on these 2 attributes and click add, and now this is what I get. And of course, within the hashtags and URLs columns, I can further nest the sub attributes as I wish to. And this is how you work with JSON data in Alteryx Designer Cloud. It's just a great and very easy way for non-technical users and business users to be able to wrangle JSON data on their own. And once the data is fully nested, we can further take this data and manipulate it, aggregate it, join it, and continue to transform the data in the way we want. Now let's run the job. What run does is it gives us the option to take the result and publish it back into Snowflake via another table. By the way, as a job completes in Alteryx Designer Cloud,
Checking into Snowflake SQL logs, we can see a series of executed SQL statements comprising of native SQL operations and JavaScript functions. These are from the pushdown optimization done by Alteryx Designer Cloud. Now, with full pushdown on Snowflake, the data transformation logic is optimized and converted to SQL statements. All the transformation and recipe steps in Alteryx Designer Cloud are converted to Snowflake native functions and JavaScript user-defined functions, resulting in the transformation being executed fully and directly on Snowflake. Now, full pushdown by Alteryx Designer Cloud brings significant benefits. Most notably, I would say, is performance, efficiencies, and cost saving. And since all transformations and processing are done within Snowflake, the data does not need to move in or out of Snowflake, making it also more secure and scalable. But I'm guessing best of all for business users and non-technical audience, we can take advantage of the power of the Snowflake platform and advanced SQL operations when working with our data, without having to become SQL experts ourselves.
Thanks for watching. Hope you enjoy the snippet of how we can deal with JSON data using Snowflake native functions and capabilities, especially for those of us that love SQLs or like to write SQLs. And of course for others who are non-SQL coders or who prefer a self-service or more visual way and a guided tool, please check out Alteryx Designer Cloud for your data preparation needs.